Everyone. Thank you for joining our recurring webinar series. Today we will be covering one of the more popular topics, Creo Import Data Doctor, which is a free module everyone has, so everyone likes to get better acquainted with what tools they already have access to and make better use of things already near at hand. Myself and Sean Faringer will be presenting this morning. I will cover about 8 minutes of introduction, and we'll hand things off to a live presentation by Sean Faringer. A few housekeeping items. Please note that all the attendees are in listen-only mode, but there is an option to submit questions to us. If you check the interface, I believe towards the top of the screen, you should see a Q&A tab. Please do submit any questions that you can. We'll certainly answer any questions we have time for during the presentation, and we'll follow up with anyone who submits a question we can't answer during the webinar. Brief agenda for today. We'll try to go quickly through this introduction and get on to the live webinar. Myself, Scott Rich, our Director of Sales here at ETRAGE. I've been working with PTC products for the last 8 years. I specialize in helping customers identify where and how they can improve their processes and share data across all divisions and operations of an enterprise. Sean is one of our best technical experts with all things Creo, a true expert, all things tool and die and manufacturing, more than 25 years of experience using Creo, and a longtime certified instructor of PTC products. A little bit about ETRAGE. We've been in business for more than 20 years. Our mission is to help customers integrate all of their enterprise systems, migrate data so they can have an eye towards the future, and make sure that PLM data is able to reach all critical team members across an organization. Some examples of our customer base. We work with anyone that does design and manufacturing. We work with all sizes of companies. We really specialize in helping these customers share their data, automate processes, especially how data is going to be shared, integrate across multiple systems, and bridge the gap when customers are struggling to get two systems to speak to one another. We offer a number of products and services. Some of our own products include the ETRAGE Viewer with a number of add-ons to meet customer needs, an ETRAGE-based document management system, our plot service for Windchill, our bulk loader for large data migration projects, and integrations with ERP systems. Amongst our services, we do any number of things with Windchill, from customizations, implementations, upgrades, maintenance of an existing system, either on cloud or on premise. We offer our own cloud hosting of Windchill, and we do a vast array of training. Today's webinar kind of falls into that training bucket. We like to provide tutorial type of content for our customers, and just to spread the functionality that's available in PTC's Creo. And some notes on training. We offer extensive training with a proper standardized curriculum or a customized curriculum based on customer needs. We offer private classes, public classes, e-learning as an excellent way to have continuing education for our customers who take in-person classes. And of course, mentoring when that is the right case. You need somebody looking over your shoulder, giving you guidance on how to do your design and manufacturing work. So about Import Data Doctor, before we get started, a few details. It's a free module. Anyone using PTC's Creo Parametric is going to have access to this functionality. It lets you easily fix and repair anything that's gone wrong when you try to open a Creo file that's been shared with you. It's intended to save users time, improve collaboration, and make sure that you don't have to go through, or at least avoid as much as possible, the need to do costly redesign work. There are a number of features in Import Data Doctor. These are some highlights to do, analyze geometry, identify defects that need to be corrected, change topological structure of that imported geometry, and so on. We will not get to all of these core pieces of functionality. We'll cover a number of things in the next 30, 40 minutes. We would love your feedback. What things do you most want to see from Import Data Doctor and other Creo tools and modules for future presentations? With that, I'll hand things over to Sean Farringer. Thank you again for joining us.
Okay. Hello, everybody. This is Sean Farringer, and as Scott elegantly mentioned, we're going to take a look at Import Data Doctor today, and we'll go through a kind of a use case with a somewhat simple part with a handful of problems in it that are effective to discuss. Import Data Doctor topics. As Scott mentioned, more expansion on Import Data Doctor, things in the future, please don't hesitate to reach out and ask. So with that being said, we'll kind of dive right in. Now, one of the big hang-ups about Import Data Doctor for a lot of folks, unfortunately, is how to access it. So here I'm just going to open up a basic example file for Import Data Doctor, and we'll go ahead and start working with it. When you import a file is typically when you're going to encounter the use of Import Data Doctor. Just so it's said, this isn't something that we typically operate on native files with, as far as that goes. Now we see here that I have an import profile established that's kind of automatically being detected for step files, and we're going to import this file in accordance with those rules that are established in that import profile. Now, when we start talking about importing data, ideally, we want to get to a place where Import Data Doctor doesn't have to do as much work. And a big part of that is properly importing objects into Creo and understanding Creo accuracy concepts, because these are very much in play when we, import files, prior to, potentially acting on them with Import Data Doctor. So I'm going to share some of my favorite stuff here today that I really advise everybody to at least give consideration to. I mean, none of this is an absolute must do this way script. However, I've built these settings and these approaches over a great number of years. So, I do share that it serves me well. One of the initial things we're going to do is we're going to make sure we're not importing to templates. When we initially import an object, we want to see the object for what it is, not necessarily what PTC makes of it. We have accuracy implications when we start using our own templates for the import. Later versions of Creo are much more stable about the model accuracy setting being applied through the use of a template, but I still, in an old school sense, if you will, don't necessarily recommend taking that approach. So we're going to go ahead and forego using a template, and I think everybody will be able to take away from this approach and what we see in this, why we don't use a template and why it might be more advantageous to establish this part as as is, bring it in, fix it, and then potentially go back and use maybe merge and synchronize the accuracy in a standard PRT file that is of our own templates, that comes with our own datums and our own parameters and setup and things to that effect for the part template, and then just match these accuracies out, and then subsequently merge, inherit the actual object that you bring in and work with an Import Data Doctor or your raw step file or whatever it might be. When we look into these objects, the most important thing you're going to encounter when we talk about a profile that you're going to import something under, and that's just accessed by the details tab, as we see back here when we go to import things like step files that take us to Import Data Doctor. If there are problems, if you will, the most important thing, in my professional opinion, is this model accuracy here, where you see this can be automatic, internal or external. Just so it's said, Sean's never a fan of anything being automatic in any way, shape, or form anywhere, let alone in Import Data Doctor, because I don't have any idea what it did or what the approach chosen will be or anything to that effect. It leaves a vagueness, and I'm just much of the school of I prefer for things to be explicitly declared. Now we talk about model accuracy. You got two effective options, internal or external. Internal says I'm going to go get the default accuracy that exists for this template model that I'm effectively importing this onto. When we forego our own templates, we take PTC's standardized template that last I knew is just a relative accuracy 0.0012 template. It's not an absolute accuracy template. When we take the external accuracy here, what we're going to do is effectively end up with an absolute accuracy template, and its accuracy is going to be matched to what is determined in the target file. That's terribly important, because if we're attempting to work with accuracy globally during the import process, it's very likely, if especially in a case where we don't know what that is, that we're going to make things worse, because we're trying to either make things better than they were in the original file, or we're allowing things to become looser in a general term than what they were in the original file. I always make a statement in these types of discussions, and it's probably the most important thing that I'll share. You don't get back math you never had. So if the target system provided you with X accuracy, that's what the accuracy of this file is. Now I could import this into a substantially more accurate PTC part template, and then pick an enormous fight fixing all of the things that will break with import, inside, using Import Data Doctor to fix all of those things. I end up with a file at the end of the day that may in fact be repaired, but the math and the surface definitions and things aren't effectively better at that point than what they were when they were originally created. So it's important to use external accuracy. Basically, after making the selection for external accuracy, I tell PTC to do nothing. When I import this file, the only thing I'm going to let them do is solidify a closed volume if it detects as much. It can go ahead and solidify that for me. But beyond that, I import everything except blank entities, and I tell PTC to leave everything else alone. So basically I'm saying, give me this external accuracy and let me see this file as is, where is, and then I know what my real to-do list for Import Data Doctor will in fact be. So we'll go ahead and say, okay, and we'll put the file on the screen now. So when we import a file and we import it in this method, we're effectively able to go back and review this file now and say, hey, okay, this is what I got. So in that case, the first thing we do is we say file, prepare, model properties, and now I get to see just what it is that I've been given. So I have a custom accuracy thing because it's very old file apparently, and units aren't really defined in it, and we have an effective absolute accuracy of 0.06. So, on face of it, this isn't a wonderful file by typical engineering standards. Arguably, I would expect people to be seeing things that are much better than this nowadays. And arguably that is the case. I mean, nowadays things are better in terms of interportability between systems than what they were 10 years ago. But legacy data and things like that still come into play. And there are still breakdowns in cross-portability between systems, even using step files and such, because not everybody pays attention to accuracy when they model things. And this is really where that starts to matter immensely, as we see here. This file does not have an enormously, high accurate definition to it to begin with, if you will. So here's the file we've got. We'll go ahead and take a look at this in hidden line mode, and we can kind of see, we've got some open stuff here, open edges and things to that effect. You can kind of see that distinction in the colors. An old school system colors works really nice for this. If you're running a very old Creo setup, or Wildfire Pro E, if you will, that was purple over yellow for these definitions, and it was really really high contrast to be able to see open things and stuff to that effect, but what we can see here visually. So accessing Import Data Doctor isn't through applications or something like that in the interface, where a lot of these things are found, or like in the case of manufacturing, saying file new manufacturing, and then you're in the manufacturing environment. To access Import Data Doctor, we edit the definition of an imported feature, and then we select the little hospital icon here. Now we are in Import Data Doctor, as we see here on the ribbon, and this is our environment to begin working on, our object and fixing our problems here, if you will. Now, one of the things to note is our first, order of evaluation here exists inside of the GTS tree, and this is where surfaces and objects are kind of defined. Now, something that's very important to note: if you intend to solidify an object, everything has to be a single component, and all of its edges have to be zipped up effectively and closed. When we talk about a scenario like this, where we have a component and we have a standalone surface, you can't tell that to become a solid object, because there are, issues inside of the import that basically have unjoined or open edges. So keep in mind, this component, which is like an assembly of surfaces, is exactly what I try and share to people. A component inside of Import Data Doctor is an assembly of surfaces, and we can add and remove individual surfaces from the component. And when we do, Creo will attempt to weld those surfaces and their edges and all these things together to the best of its ability. It may not effectively be able to do that because it's, the edge definition is insufficient, or, bad data, whatever the case may be. But it does attempt to do that to the best degree that it can, and put things back together. But again, this is your assembly of this object as surfaces. Now, when we select our surface here, because we know looking at this, that this is a problem, we can't have both of these things. So we see, and we highlighted over here, and we see the zebra stripe that kind of indicates that there's a very high likelihood we got two things sitting on top of each other. So I'm going to right click on this, and you've got a whole menu of options to work with things through the GTS tree. And this is, as Scott kind of alluded to, we have a limited amount of time today, so there's just, it's a deep topic, and we're only going to be able to touch so much. But one of the things I'm going to use right here to do a simple evals hide that. So that surface is hidden now, and I still see an object underneath of it. So that's got to be a part of this component. So that means this surface that I've effectively hidden, and of course I can unhide it also, that surface that I hidden is unnecessary. It's redundant and provides no value. It's not inside of the component, and it would effectively prevent us from solidifying this object if we wanted to. So we're going to go ahead and delete that. So it's gone and subsequently deleted now. Now we see here in our object, we've got a host of different issues that exist in terms of this primary surface is bad. Now, when we're looking at it, we need to do some evaluation with sanity. And one of the first things I want to determine is this surface the whole problem? Okay, because the way we utilize Import Data Doctor comes in a lot of different ways. And, we have a lot of issues with this surface. Now, it's effectively, obviously, to be a planar surface at the end of the day that subsequently seals up the shape that we see here. But when we talk about, is this surface the whole problem, what we mean is this surface are all of our issues on this surface? And we see that the deviation from the desired line here is definitely part of this surface. When I'm looking at these edges on this surface, it's effectively not, the edge on the fillet is okay, I guess is the easy way to say this. But the edge on this subsequent surface that's in green is what's not okay. And we see we have a lot of that going on here. We have it, basically all over this surface, and we have an issue down here in the corner. Now, we do have a lot of tools like move vertex and stuff, where I can effectively go in and grab this edge and then start moving it and dragging it and dropping it in close proximity to this other node here, and then it will attempt to weld it in. But see, we've got other issues. See, we've got, when we go to select on this, we see that we have a broken line here. Now, we of course would want that to be a single continuous line that went all the way across, for this particular surface, through here. So, the surface has a great many issues. So we can definitely utilize tools, to repair the surface. And I would encourage, in a case like this, you can absolutely start with a repair. Now, the thing about repair is, a lot of people open up Import Data Doctor if they get this far, and they just blast this repair button and say, go fix the whole file, because you can. That's a horrifyingly bad idea. For a million reasons, because PTC is going to effectively work on topology all over the model, and we don't have problems all over the model. So it effectively doesn't make sense to do that at the end of the day. We want to do repairs in a localized sense. Now, when we have multiple components and we're working on things, you have to activate the component formally in order to be able to select and do surgical repairs, if you will. A surgical repair would be the context of selecting this surface that I know is messed up and saying repair. Now, notice the difference here. I'm only working on this surface, okay? I'm not working on the whole model. Now we see here in the preview what I'm going to get from this surface in terms of its repair. Now this definition's not going to be fixed down here in this corner, largely because of our broken edge, but it does seem like it might clean up a couple of these breakouts up here by the fillets in the U shape. So we go ahead and we say, okay, well, it didn't effectively clear that up. Well, see, that's the thing. A lot of folks will continue working now, and that's a really bad idea. When you tell Import Data Doctor to do something and it doesn't succeed, you need to tell it to undo that thing, okay? Because at the end of the day, that stuff is stacked historically in the memory of all stuff you're doing here, and it does you no favors to kind of keep those attempts at repair, and then they failed, if you will. Now, another part of the Import Data Doctor scenarios that we have is things like replace. And I can select this edge here on the surface that's bad. I can say I want to replace that. I select my adjacent edge and I say okay. And you see the replace that just took place. No pun intended. It solved solved that edge issue straight away just by doing a quick replace. Now, when I could kind of continue to do that around here and then play around with some move vertex and some stuff down here, and then patch in my surface here and things to that effect. But at the end of the day, a big part of working on these files is recognizing, you don't have to do it all like this. And sometimes the approach is best handled in a hybrid method utilizing Core Creo and Import Data Doctor to do some real cool stuff. So that's a little bit of the approach we're going to take on now. So I did this repair on that edge and stuff to that effect. I'm going to go ahead and effectively undo that, as I mentioned. Now we're going to grab this surface and I'm just going to say delete. So I'm just going to get rid of the whole stupid thing. Now, the next thing I want to do is I want to grab these two edges down here that I know are broken like that. I'm going to do a merge curves on that. And then now I'll have a single edge on there. And that's going to be beneficial to, the approach of what's coming. So now we're going to go ahead and say, okay, we're going to back out of Import Data Doctor. We're going to do what's effectively some really cool stuff. So the first thing I'm going to do is I want to replace this surface as a whole. So I need a datum plane to put it on because as we know, it was to be a planar surface. So I'm going to go ahead and put a datum plane through those two far edges. And then in this case, we're going to go ahead and say we want to make a fill surface. And now we're going to go ahead and project some stuff, right? So I'm going to see if I can grab a chain around here, and we'll grab the chain hopefully from there to there. Yes. And we're going to go ahead and accept that. And now hopefully it makes sense why I did that edge thing there. Now you see we got a little bit of baggage here where it blew off the corner and stuff to that effect on here. These things can be kind of attributed to the crappy file accuracy that we reviewed coming in. And then we would obviously want to clean this garbage out because it's not going to be part of our surface at the end of the day. We don't want any part of that stuff in there. I'm going to go ahead and effectively use a trim to corner on that to clean that corner off. And no, I've still got a straggler on there. So we'll delete that out. There we go. So now I've got a surface merged off on here. We, of course, need to fill in the piece that's missing here with the tangent arc as such. But now I should have, we got a couple of open edges we got to clean up here with some trim to corner. And again, when you're dealing with a file that has as poor of accuracy as we discovered this file to have in the beginning, these types of trimming operations and these types of things are not going to be unusual. So we're going to go ahead and say, okay, there we have our new surface coming in into the model pool, if you will. Now, a lot of folks get offended by the concept of having to use merge and stuff like that. Now, we're not going to do it that way. We're going to do what the cool kids do, and we're going to put it back into the import file and kind of make it like this all kind of never even happened, if you will. So the next thing we're going to do is we're going to do our boundary blend now while we're at it. We could do this inside of Import Data Doctor, but because of the approach we're taking, we're going to go ahead and just do it now. So we're going to put a boundary blend in that corner to fix that up, that corner that's missing effectively, if you will. And then what we're going to do is we're going to go ahead and down here on the end of this, we have a collapse. And a lot of folks don't use this and aren't familiar with what it does, but we're going to select these features in advance. And, of course, it comes up to say range of features and, what do you want to put in there also, as a part of these things that can be collapsed into the import. So we're going to go ahead and say we're going to collapse those features. And oops, I got to undo that. I didn't, nope, there we go. We got to grab all three of these things and say collapse and the range of features, or I'm sorry, maybe, no. There we go. Yes. And then we'll collapse those in. And now I have all of these objects inside of my import feature. I don't have a separate Creo surface for the, these two things, but this is not all effectively put together. So if I go into no hidden mode, now you can see that there's still purple stuff going on. And it's not, we can't knit this off to a solid. So we're going to go back into Import Data Doctor now. And now we're inside of Import Data Doctor, and we see what's kind of going on here. We've got a datums folder that brought over the datum plane that I made. We can go ahead and delete him. We don't need him inside of Import Data Doctor. But now we see we've got this big component and a couple of surfaces. There's the two surfaces that I built. Well, of course, we want to drag and drop these guys into our component to kind of sew everything together to the best of the ability that it can. Now you see here that I've still got some open stuff going on here with these surfaces down here, but it knitted up all the rest of the stuff on my model. So what we're going to do now is we're going to go back and check a surgical repair and see if we can clean that up that way. And this is what I'm going to select. Now, when I come at this and do a surgical repair, I see I have an open here and I have an open here on that red line. I'm not just going to go stab the repair button like I mentioned. We're going to go ahead and grab everything that's adjacent to those problems and only the surfaces that are adjacent to those problems. And then we're going to do a repair on that. Now we see those lines going green. That's a good news. And we'll go ahead and say, okay. Now, we did a surgical repair. We didn't tell Creo to go in and, and fight the good fight for the entire file that we're looking at. We just did it here on the surfaces that mattered, and they, fixed up accordingly. So this file doesn't have any more open stuff in it. We've used a couple of Import Data Doctor tools to kind of repair the file and use, a couple of different approaches and stuff to that effect. Now we can effectively back out of this file from Import Data Doctor. We can click our solidify button and we'll say, okay. And now you see that, whoops, if I get back to shading with edges, now you see that all the display has changed. And I do, in fact, have something that came out of Import Data Doctor as a solid. Now, one of the things I did do is I clicked give me the import as a solid now when I walked out of edit definition. Because now that I've fixed all these things inside of Import Data Doctor and outside of Creo using some of the power tool of collapse, I've got a good model now, and there's no reason it can't be a solid. So if I leave it set as a surface, then when I back out of Import Data Doctor, I have to come in, if I want a surface, if you will, or it should be a solid body, I would have to come in and select this as a quilt and pull a solidify on that. And now I have a solid all the same, but I have a solidify feature that defines that inside of, inside of the model. And some people have a preference one way or another. You get the same result either way. If I walk out of Import Data Doctor and I say, or, out of the dashboard for edit definition, after I've done my work in Import Data Doctor, I say import as solid, I will get a solid, and we absolutely can go and calculate mass properties on this object. And it is a solid because we are getting mass for the object. So, the densities and the material applications and all that stuff notwithstanding, it does calculate a value, which tells us that we do, in fact, have a good solid model. So that's kind of like, a quick walkthrough approach of how I encourage people to think about approaching things inside of Import Data Doctor and using the tool and core Creo to get the best results the quickest. If I were to import this file onto my own part template, and the accuracy on my part template, so like when I say file new part, this is the default accuracy that I'm getting in this configuration that I'm showing in Creo today, which is inch absolute a tenth. The file obviously was not that. When we received this file, we received a file having that accuracy, absolute 0.06 and change. You can want this to have better math, but you will not get it. You can't get back math you never had. So when we import this in this technique and we see that this is the originating accuracy, we can wish for better, or we can potentially request better from the originator. But there is no magic, is something that everybody needs to appreciate. When you start messing with this accuracy, you're effectively doing manipulation of this surface edging at best. The curvature definition or planar definition, the underlying topology definition is not subsequently being rewritten to this new standard because we're manipulating the accuracy inside of Creo. That's absolutely not the case. All you're doing is potentially making more work for yourself or relaxing those features in such a way that you are losing accuracy from that which was provided to you. And again, the simple part of it is you don't get back math you never had. So making things go like you saw it here today, this afternoon inside of Import Data Doctor, a big part of that is recognizing that we do this with sane accuracy, because we have to care about that when we're trying to deal with interportability, between two systems, whatever that is, SolidWorks and Creo and CATIA, different things to that effect. And, it's also worth saying, I usually mention this somewhere along in one of these demonstrations. It's the year 2024. Friends don't send friends IGES files anymore. If you're getting IGES files from somebody, reach out to them and discuss with them what the problem might be, because any system worth its salt in the modern era, whatever that is, whether it be Inventor or, again, CATIA or NX or whatever, Creo itself, indeed, you provide files to other people as well. We should all, I think, as a community of engineers and designers and modelers, all of us should pretty much be working with the STEP standard now. IGES files are of poor quality, of poor definition, and unless you're out to really punish a vendor or something to that effect, there probably isn't a good reason to send out one of those. But this is also the case for our own side. It is worth mentioning. This accuracy that exists here under model properties, file prepare model properties, when we're making our stuff, that accuracy is what you potentially give somebody else. Model-based definition is an evolving, becoming thing nowadays. And when we talk about the concept of handing off a 3D model via some neutral format, shall we say stop, because again, friends don't send friends IGES files, we're handing them that accuracy from us in the same way that we're evaluating that accuracy on the other side. When we talk about Import Data Doctor, that applies to us because we have the same, effective problem of two accuracies. We have our accuracy inside of Creo, and we have an accuracy inside of this file that we're working with coming into Import Data Doctor. We want to make sure those things are on the same page. And the way we do that is by opening objects, opening these import objects, as I did here, utilizing external accuracy. So you're going to go to your detail. If you don't have profiles and those types of things defined, I think you maybe benefit from that, and I would encourage you to give that a consideration. But absent that, you can always fire off this details tab. You come in here, you set the model accuracy to be external, and you don't import this thing on your own template to begin with, because you're going to potentially end up with the accuracy from your template, and that could be like a horrifying relative accuracy type scenario where you're going to regenerate the whole accuracy on the model based on its size. That's really going to potentially cause problems in a lot of cases. So the best way, like I said, is to uncheck templates, import this on external accuracy, take a look at what you got, because that file, as is, where is, when we imported that the first time, and I told Creo to leave everything alone, do nothing, fix nothing, join nothing, do nothing, give me the external accuracy. That's when I get to see this as is, where is. That is the real to-do list for Import Data Doctor. If you manipulate the accuracy on import, either by attempting to reduce it or increase it based on your own templating or some other formula of import that doesn't use external accuracy, it's very likely there will be increased efforts inside of Import Data Doctor, or it will result in effective topology loss in terms of data quality definition in 3D. So, it all starts here. Tell PTC not to fix it. You don't know many things don't need fixed. If you're taking files between some of the high-end modern systems, especially in like automotive, medical, or aerospace communities, everybody's pretty much on board now. And chances are you don't do that file any benefit by telling PTC to manipulate it. Import Data Doctor should have to be used very little nowadays. I find most of in my own work, what I have to do is fix things like logos, where somebody has a custom logo that's been extruded down into a part, oftentimes on a surface of curvature or, you know, non-planar definition. And a lot of those things have a lot of small curve definition and things to that effect and stuff going on in them. And, you know, most often I'm going to see a breakdown, or if I'm going to see some form of breakdown, it might be related to something like a logo on a part that I'm importing. But, you know, the definition of everything nowadays, everybody does a better job of making a step file now than they did 10 years ago. We have less to do in Import Data Doctor, but it's important to see that for what it is and not potentially increase the to-do list by, you know, importing this and attempting to shift the accuracy as part of that process. So with that, that kind of concludes my time scope that I'm kind of allotted for Import Data Doctor discussion today. There's obviously, as I mentioned, a lot to talk about. There's an enormous amount of feature set with inside of Import Data Doctor. We only got to touching on a little bit of it, repairing things, you know, replacing some edges, merging some curves, some stuff like that. We can also define gaps and then repair those. That's a little bit different workflow. We have to, you know, define the gaps, add these things to the wireframe, and then, you know, when we do a repair, it will automatically heal those up. But that happens in conjunction with repair. And I personally find that if you're not offset with accuracy in some net negative way, in most cases, repair, as you watched when I used it on these three surfaces here in this corner, repair takes care of a lot of stuff pretty straight away without needing a lot of help if it's not trying to do it to a different standard than what the originating system provided. So with that, I appreciate everybody's time this afternoon. I thank you very much for participation. I'm going to hand this back to Scott for any final comments. And we'll obviously be taking feedback from this in terms of future content and follow-ups and things to that effect. And thank you.
Sean, if we have time for one question that was submitted, when would we use UV as compared to XYZ?
UV as opposed to XYZ. Can we have them expand on the question? Because you know, I guess I am not, I guess I'm not right on the face of it, sure of it being lined up with the question. So hopefully we can get a little bit of it, you know, a little bit of additional information there about, you know, what they're, I'm happy to answer the question as soon as I better understand it, I guess is the moral of the story.
Some clarification in the 4 tabs when you set to nothing.
Run that by me again, Scott.
Yeah, let's go ahead and table this, and I will set up a call with the yourself and the person who submitted the questions. Hopefully we can do that as early as this afternoon.
Oh, okay. I just caught the question. I see now. Okay, hang tight. So I believe we are talking about here, maybe. And my apologies to the questioner if I'm getting this wrong. But I believe they are questioning something in here. This boundary preference, UV versus XYZ. Is this correct? Am I online now with the question? Okay. All right. Cool stuff. Preference XY UV. Very much so. So use intersection curves in XYZ if available. Use half edges in UV if available. In my own personal experience, when we talk about which would we use and when, UV has the greatest compatibility with the greatest diversity of originating files. I have seen very few files that import, you know, better or, you know, provide some, you know, improvement or outright compatibility with boundary definitions as XYZ as opposed to UV. This is one of those things where I would actually share. This is probably a good default. at the end of the day. It really is to keep. I would share that I don't have a conscious memory of the last time I needed or benefited from the XYZ boundary preference. But very good question. And there are an enormous amount of details here as it relates to how you're importing and handling those things. But again, single most important thing is no templates to start with, and model accuracy is external. So you can have a look at what you were given in order to follow from that, as opposed to trying to do something with that file before we know that it wasn't good to start with. Good question. Thank you. And happy to answer questions and stuff to that effect.
Thanks again for attending our webinar on Import Data Doctor today. This will close things up. We hope to see you at one of our upcoming regional user group events in the next 2 months or at our next remote webinar session. Have a good day.